So what shall we do in the case where we have square root of a squared plus x squared? Well, if you recall, suppose that we have our trig identity sine squared theta plus cosine squared theta is equal to 1. And if I were to divide everything by sine squared, let's do cosine squared theta. The result that I will get will be that tangent squared theta plus 1 will be equal to secant squared theta. And most likely what we will do is we will set the x equal to tangent theta to then solve for this. We have the integral dx over 4 plus x squared squared. And so x will be equal to 2 tangent of theta, and dx will therefore be equal to 2 secant squared of theta d theta. So the entire numerator is going to be 2 secant squared theta d theta. We have the integral in the denominator. We have 4 plus 2 tangent theta. This I'll put in brackets that are going to be squared with another squared. And so the first thing that we do is we're going to simplify the denominator. So we get 4 plus 4 tangent squared theta. That's going to eventually be squared itself. Numerator still stays the same as 2 secant squared theta d theta. And the 4 plus 4 tangent squared theta, we know it has to be equal to secant squared. So in the denominator, we have 4 secant squared theta, which then has to be squared. In the numerator, we have 2 secant cubed theta d theta. This simplifies to 16 secant 4 theta in the denominator, and the numerator still 2 secant cubed theta d theta. And so we see we have a secant cubed in the numerator, we have a secant fourth in the denominator, so that's going to leave us a 1/8 integral of a remaining secant in the denominator d theta, and this will simply just be 1/8 integral of cosine of theta d theta. That's an easy integral that we like to do. So looking into this theta, so looking ahead, we see that we originally set that x equal to this 2 tangent of theta, which tells us that tangent of theta is going to be equal to x over 2. Therefore, when I look at my first quadrant triangle, I see that the opposite side is going to be x, the adjacent side is going to be 2, so therefore the hypotenuse is going to be square root of x squared plus 2. And so first, when we take the integral, we get 1/8 sine of theta plus c. And with the sine of this angle will be x over x plus 2, so we get 1/8 x over x squared plus 2, where the x squared plus 2 is under the radical, plus c as the answer. To do one more example from this particular section, let's try number 26. So number 26 has the following. We have the integral from 0 to 3 of x cubed divided by 3 plus x squared raised to the 5/2 power dx. So generally x is going to be equal to square root of 3 tangent of theta, in which case dx is going to be equal to radical 3 secant squared theta. X squared is going to be 3 tangent squared theta. And so we have this x cubed term in the numerator. That's going to be equal to square root of 27 tangent cube theta. And let's also remember our limits. So we have essentially when x is equal to 0 and x is equal to 3, these will have to equal radical 3 tangent of theta. This will be equal to radical 3 tangent of theta. And so the first one is tangent of theta is going to be equal to 0. That's going to be 0. For 3, we have tangent of theta is going to be equal to rad 3 over 3, which is just equal to radical 3. And so a radical 3 would be when we have a tall triangle in which we have this side as 1/2, this side as rad 3 over 2, and that's going to be the case when we have pi over 3. So therefore our limits are now from pi over 3 to 0, and we have the numerator is going to be equal to the radical 27 tangent cube theta. Denominator, we will have 3 plus rad 3 tangent squared theta, and that's going to be 3 secant squared theta. And this 3 secant squared theta is going to be raised to the 5/2 power. And the dx is going to be replaced with radical 3 secant squared theta. So the next, we have 0 to pi over 3. The radical 27 and the radical 3, they're going to multiply to radical 81, which the square root of 81 is going to be 9. Numerator, we have tangent cube theta, and we have secant squared theta d theta. The denominator in this case, so this 5/2 is going to apply to both the 3 and the secant squared respectively. So we have 3 to the 5/2, and we have secant squared to the 5/2 is going to be secant to the 5th power theta. Next step, from 0 to pi over 3. So we have this 9, we have this 3. If you want to reimagine this, we can imagine the 9 as 3 squared. The denominator is 3 to the 5 halves. That allows us to easily figure out what is going to be the numerator divided by the denominator of same basis when the exponents are different. We're just going to be subtracting them. We have essentially tangent cubed in the denominator, and we have secant cubed in the denominator d theta. Integral from 0 to pi over 3. So when we do 2 minus 5 over 2, that's going to be 2 minus 0.5. That's going to leave us with a radical 3 in the denominator, which we can factor out because it's just a constant. We know that this is going to be equivalent to tangent cube theta. And the secant is actually 1 over cosine. And with 1 over cosine in the denominator, that's going to move cosine cubed into the numerator d theta. Now remember, tangent is actually sine over cosine. So we have 1 over radical 3 from 0 to pi over 3. Sine cube theta over cosine cube theta times cosine cube theta d theta. That allows these cosines to be simplified. So we have 1 over radical 3 from 0 to pi over 3. And because this is an odd power of sine, we can write this as sine of theta times 1 minus cosine squared theta d theta. And we are going to then do another u substitution. So when we do u is equal to cosine of theta, the u for pi over 3, what is cosine of pi over 3? That's going to be 1/2. What is cosine of 0? Cosine of 0 is going to be 1. And so we have essentially changed the limits of this integral. We have du is going to be equal to negative sine theta d theta, in which case negative du is going to be sine theta d theta. So the sine theta d theta is going to be replaced with a negative du. And what's quite interesting is that the limits actually have it so that we have a smaller number in the numerator and a bigger number in the denominator, which then we will account for with this negative when we flip it. We'll see that in the next step. And we're just left with 1 minus u squared. So in red, if I were to add some more space, the first thing I'm going to do is I'm going to get rid of the negative by switching the limits. So we have a positive 1 over rad 3 integral from 1/2 to 1, 1 minus u squared du. And so when we integrate, we get u minus 1/3 u cubed, with limits of 1/2 and 1 being substituted in. And so when we substitute everything in, we get 1 over rad 3, 1 minus 1/3 by placing in the original top limit 1, and in the denominator, so we will have 1/2 minus, so when we have 1/2 to the third power, that's going to be 1/8. 1/8 times 1/3, that's going to be 1 over 24. And so when we do 1/2 minus 1 over 24, this is really 12 over 24, so we're going to get minus 11 over 24. 1 minus 1/3, that's going to be 2/3. And so in order for us to have, subtract these two, what we would have to do is we have to multiply this by 8 over 8, so that's going to give us 16 over 24. So 16 over 24, that's going to give us 15 over 24. And in fact, 15 is a multiple of 3, 24 is a multiple of 3, so that's going to be written as 5/8. And so therefore our answer is going to be 5 over 8 rad 3, but we can't have a radical in the denominator, so this is going to be 5 rad 3 over 24, just due to those limits alone. And finally, the third type of problem that we expect is when you have a difference of squares in which x is going to be the first term. And that involves replacing with the secant. So we have square root of x squared minus a squared. Let x is equal to a times secant of theta. Now, as we recall, when we do our trig identity, we have sine squared plus cosine squared theta is equal to 1. So when I divide everything by cosine, and I'll just abbreviate it with the letter c, I get tangent squared theta is plus 1 is equal to secant squared theta. And so the secant squared theta minus 1 is going to be equal to tangent squared theta. And that's what we expect. So next, the example problem that we will do, let's do something quite challenging like number 11. So we have the integral dx over x squared square root of 9x squared minus 4. So the idea is typically you want this term in front of the x squared to be the same as the number that you're going to be subtracting. And so ideally, if x squared became something 4/9 times something else. Then that 4/9 would multiply with this 9 so that you have both terms as 4. So x in general has to be 2/3 of some other term. And so that's how we identify our a term. X is going to be 2/3 secant theta. Dx is going to be equal to 2/3 secant theta tangent theta. And that tells you that x squared is going to be 4/9 secant squared theta. So this entire radicand will be 4 secant squared theta minus 4. That's going to give you tangent. And therefore, when we start distributing, we have 2/3 secant theta tangent theta d theta in the numerator. In the denominator, the x squared is going to be 4/9 secant squared theta. In the denominator, now we have 9 times 4/9, that's going to give you 4 secant squared theta minus 4. This 4 secant squared theta minus 4 is going to give you 4 tangent squared theta, so we have 4 tangent squared theta under the radical, 4/9 secant squared theta, all over 2/3 secant theta tangent theta d theta under the radical. The radical itself, when we simplify, it's going to be 2 tangent theta multiplied by 4/9 secant squared theta. Numerator is going to be 2/3 secant theta tangent theta d theta. In the integral, the tangents cancel out. So one of the secants will cancel out with one of the secants, so I'm only going to get rid of that squared. And so what we see is that, okay, so we have 2/3 in the numerator. We're dividing by 4/9 and 2. So this is 2/3 divided by 8/9. Dividing by fractions is the same as multiplying reciprocals, so we have 2/3 times 9 over 8. This we could simplify where that's 1 and 4. This is 3 and 1, so that gives us 3/4 outside integral. And because we have a secant to the first power in the denominator only, that's just cosine in the numerator, d theta. And earlier we made a relationship with the x such that x is equal to 2/3 secant theta, which is really secant of theta is going to be equal to 3x over 2. Now, I know that secant is going to be 1 over cosine, so this is really 1 over cosine theta is going to be 3x over 2, in which case cosine of theta by itself is going to be 2 over 3x. So that tells me if I have a first quadrant triangle, then the adjacent side is going to be 2, the hypotenuse is going to be 3x. So therefore, this is going to be 9x squared minus 4. And so therefore, of this theta, we want the cosine, which is going to be 2 over 3x. But since we're integrating, this integral is going to give us sine. So we have 3/4 positive sine theta plus c. And therefore, the sine of this will be, so 3/4, the sine theta is going to be the square root of 9x squared minus 4 all over 3x plus c. And if we simplify this as best as we can, then we get the 3's are going to cancel out. So we get square root of 9x squared minus 4 all over 4x plus c as our answer.